Good afternoon to all. Am I audible?
Good afternoon, sir.
Good afternoon.
Nonsense.
Okay, fine. I am sharing my screen. Please let me know whether it is visible or not. Okay. Is the screen visible?
Yes, sir.
Okay, fine. So we are going to discuss the Chomsky classification of language. If you remember, we have talked about type 0, type 1, type 2, and type 3 of languages. Which type we have discussed in these four recently? Anyone?
Type 3.
Type 3, that is called as a regular language.
Regular language.
Okay. So correspondingly, you can see here, if we talk about languages, we have automata. Just try to understand. Type 0 corresponding automata is what? It is called Turing machine, TM. Okay. In case of context sensitive or type 1, the corresponding automata is called LBA, linear bounded automata. In case of context free or type 2, the corresponding automata is known as PDA or push down automata. And in case of type 3, you are very much aware of this finite automata. So the language accepted by finite automata is called as regular language. Okay. So this is, I think, clear that we are going to have discussion on these four types of languages. True or false? Is it clear?
Yes, sir.
Now, we have already discussed how to represent a particular grammar. These are the four tuples. V stands for variable, that is finite non-empty set of non-terminals, also called as non-terminal alphabet. Okay. T is what? T stands for terminal alphabet, that is finite set of terminal symbols. So this T is what? Finite set of terminal symbols. P stands for set of production. So P stands for set of productions, also known as production rules, or simply it is called as rules. Okay. And S is what? Start symbol. So S belonging to V is the start symbol. Now if we want to find the language generated by this grammar G, then what we have to do? We have to find out the strings that are derivable from this start symbol. So language can be defined as the language generated by grammar G is equal to VTPS is the set of terminal strings derivable in the grammar from this start symbol. Analytically, we can write it L of G is equal to set of strings of what? Set of string W. W is nothing but belonging to star closure of T, and this W is derivable from S in 0 or more steps. This symbol, it is called as, or it is read as, directly derives. So this is read as directly derives. And if we talk about this star closure of directly derives, then it is nothing but reflexive and transitive closure of directly derives. Okay, so suppose if you are having one production, U is rewritten as V, fine. And if you are in one of the form like alpha U beta, and if you want to apply this production rules over this string, then it can be changed as alpha V beta by using this production rules. Fine. So we can define language. क्या होता है लैंग्वेज किसी ग्रामर के करेस्पॉन्डेंस में? कौन बताएंगे? यस, मुकेश.
Yes, sir.
लैंग्वेज जनरेटेड बाय अ पार्टिकुलर ग्रामर कैसे हमने फाइंड किया?
सर सेट ऑफ स्ट्रिंग्स है.
सेट ऑफ स्ट्रिंग्स, लेकिन कंडीशन क्या है उसमें? यहाँ देखिए, लैंग्वेज जनरेटेड बाय ग्रामर जी इज व्हाट?
Is W.
सेट
Is a
ऑफ
set of
स्ट्रिंग,
string,
ठीक है?
but string belongs to star closure of terminal symbol.
And this string, all such strings are derivable from the start symbol. ठीक
Yes,
है?
sir.
ये बेसिक
Yes,
कंडीशन.
sir.
Okay, fine. Now, if we talk about type 0 language, then there must be the grammar corresponding to type 0, and you know grammar is represented by VTPS. So this phrase structure grammar or type 0 grammar is combination of this VTPS 4 tuple representation, where V is what? Finite non-empty set of non-terminals. T is what? Finite set of terminal symbols. P is what? Set of production rules. And S is the start symbol, where production rule is of the form this. U is rewritten as V, where U belongs to, इसको ध्यान से देखिएगा, U belongs to star closure of V union T followed by V star closure of V union T. It means what? At least one non-terminal or one variable must be on the LHS of the LHS of the production rules. And right side is what? V, and V is belonging to star closure of V union T. So terminal and non-terminal combination of V and T. Fine. Non-terminal is what? V, and terminal is what? T. So any combination of V and T is permitted on the LHS, and any combination of V union T is possible on the RHS, but the restriction is that at least one variable must be there on the LHS of type 0 grammar, and the language generated by such grammar is called type 0 language. Okay, so before we move further, just write down this question. Okay, सभी लोग लिखिए क्वेश्चन. Let G is equal to VTPS be the grammar where V is equal to S, T is equal to AB, P is the set of production rules. Number one is S is rewritten as ASB, and number two is S is rewritten as AB. You have to find out the language generated by G. Okay, क्वेश्चन क्लियर है? Yes or no?
Yes, sir.
क्या फाइंड करना है?
So language generated by Z.
Fine. So you have the production rules. What you have to check? क्या चेक करना होगा? If we are finding the language generated by Z, then we have to find out all such strings which are derivable from this start symbol. Okay, so only one variable is there, that is the start symbol. So we will try accordingly. Just see here, applying production rule 2, what we are going to get? AB. This string is going to be derived from the start symbol, so we can say that AB belongs to L of G. Next, just apply first production rule, that is ASB. But this is not combination of terminal symbols. We have this variable, so what we can do? We can apply the second production rule, that is S is rewritten as AB. So this S is going to be replaced by this AB. So A, AB, B. This S has been replaced with this AB by using the production rule 2. So we are getting the string as AABB, which is derived from start symbol. So we can say that A square B square belongs to L of G. Again consider S is rewritten as ASB. Again first is used, so this S is going to be replaced by ASB by using this production rule. S is rewritten as ASB. Now we can use the production rule 2 to get AA, AB, BB. So we are getting the string as AQ, BQ belonging to L of G. If you have gone through the definition of language, that is all such strings derivable from the starting symbol will constitute the language generated by this grammar G. So we have seen AB belongs to L of G, A square B square belongs to L of G, and AQ BQ belongs to L of G. So what we can see here, number of A's is equal to number of B's, whether in this case or in this case or in this case. So we can generalize. Suppose we apply rule 1 n minus 1 times and then rule 2 1 time. So we are going to get a string of the form a n b n. So we can say that a n b n such that n is greater than equal to 1 is the language generated by this grammar. Okay, just verify for A4 B4 in your copy. You have 2 minutes. Is this clear? Yes, Avinav,
Yes.
Yes, sir.
is this clear?
Yes, sir.
So just try to verify whether A4 B4 belongs to this language or not. What do you have to do?
Sir, applying the production rules.
So one production rule 1 will be applied how many times?
Sir,
3
three
times.
times.
Very good. And then production rule 2?
1 time.
Okay. So I think it is clear for all of you how to generate language with the given production rules of a grammar.
Yes, sir.
So just try for this. You are provided with a grammar G is equal to VTPS, where V is equal to S, T is equal to ABC, and 3 production rules are given to you. Okay, you have to find out language generated by this grammar. Okay, just do this exercise in the same manner. I am waiting for 2 minutes.
Sir, just till the production rule 3, it is not visible.
Production rule 3 is just like this. S is rewritten as C.
Thank you, sir.
So those who have completed, just in they can write in chat box yes. At least one string you must have identified, which is part of language. Himanshu,
Yes, sir.
what is that string which is directly derivable from the start symbol? Hmm?
No ideas.
Okay. A string is going to be combination of these three symbols A, B, and C, because we are talking about terminal symbols of A, B, and C. The second tuple T. Okay. Variable consists of what? This S, only one non-terminal is there. All such strings, that is combination of A, B, and C, zero or more combination of A, B, and C, which is derivable from this S, is going to be part of the language generated by this grammar. Okay, so just see here, by using production rule 3. What is this production rule? S is rewritten as C.
C.
So S directly derives C.
Yes, sir.
C belongs to the language
Language
generated
of
by.
C.
So this is directly derivable. Next, suppose we apply production rule 1. Okay, so you are going to get what? S is directly deriving ASA, but this is not the combination of terminal symbols only. Here one non-terminal is appearing. So we have to replace this by a terminal string. So you have to use the production rule 3, that is S is rewritten as C. So by applying this A, C, A. So ACA will be the part of the language generated by G. Okay. This string is derivable from start symbol. Again, just try to use second production. That is B, S, B. Again, combination of terminal and non-terminal is appearing. So we want to use third symbol, third production rules. That is B, C, B. What is actually happening? This S is being replaced by C by using this production rules. So again, what we can write? BCB is belonging to L of G. Now just try combination of 1 and 2 in any order. Just use first production rule, that is A, S, A, and then the production rule 2, that is S is rewritten as B, S, B. So this S is going to be replaced by B, S, B. So A, B, S, B, A. Again, this is not the string because non-terminal S is appearing here. So we have to use what? Third production rule. A, B, C, B, A. Now we can interchange. So A, B, C, B, A, it is belonging to language generated by the grammar G, L of G. Suppose we start with the second production rule, 2. So B, S, B, then we use the first production rule. So B, A, S, A, B, and then the third one. So B, A, C, A, B. This is also derivable from the start symbol belonging to L of G. So can you see any pattern here?
Yes, sir.
Yes, sir. ये balance
Yes, sir.
What is actually happening?
Repeating values, sir.
Suppose if I talk about this, the string before C as W, then after C you are going to see what? WR,
Reverse.
reversal of this string. Okay, So we can generalize, if you remember, W is equal to A1, A2 till AN, WR is represented by AN, AN minus 1, A2 till A1. ऐसा ही था ना कुछ?
Yes, sir.
Yes, sir.
So we can generalize this. L of G is equal to WC, WR, W belonging to what? T star. Combination of what? A, B and C. ऐसा है?
Yes, sir.
ध्यान से देखिए. अगर
हाँ सर.
कोई करेक्शन है तो उसको आप तुरंत करें.
Correction.
ध्यान से देखिए और मुझे बताइए कि क्या सही रिप्रेजेंट किया है मैंने?
Yes, sir. सही है sir.
सही है. देखिए ध्यान से, T consists of what? A, B and C. ठीक है? If I write like this, W is belonging to star closure of T, then any combination of A, B and C can appear in W. But
Yes, sir.
this is not the case here. You can see in W only A and B are appearing, and after C the string is going to be reversed because the production is of the form what? ASA or BSB. Fine. So this thing is not correct. What you have to do? You have to take the combination of what? A and B only. L of G is equal to WCWR such that W belongs to star closure of A and B. In first case, you can see here only C is there. So W is the empty string. Reversal of W is also what? Empty. So you are having C as what? Epsilon followed by C followed by epsilon. That is nothing but C. Here in this case, W is what? A, WR is also A. In this case, B, B. In this case, W is what? AB and WR is what? BA. In this case, W is what? BA and reversal of W is what? AB. So we can generalize this as WC, WR, where W belongs to star closure of A and B. Now I think this is clear. Yes?
Yes, sir.
Okay, fine. Now, before we move for type 1 or type 2, just we have to know about left context, right context. So consider this production rule. Phi A psi is rewritten as phi alpha psi. Okay. If you see here, just compare LHS and RHS. What are the things that are same or identical?
Sir, phi and psi.
Phi and psi. So this is called the left context. Okay, and this is the thing as right context. A is the variable non-terminal and alpha is replaced by using certain production rule. That is this production rule. So alpha is the change of what? This A. This entire thing phi alpha psi is called as the replacement string. So as an exercise, what you have to do, you have to find out, you have provided with these three production rules. ABCD is rewritten as ABCD, AC is rewritten as A, and C is rewritten as epsilon. Find out what is left context, right context, A, value of A, that is variable, value of alpha in these three productions. Just do it. First production, लेफ्ट कंटेक्स्ट कुछ दिख रहे हैं? Yes.
So AB is left.
AB is the left context. Or you have AB common here, the same thing. What about right context?
BCD.
BCD.
BCD. So right context. What is alpha?
Alpha is AB.
AB, and this is the AB. What about this production?
A is left context.
A is left context. Okay. And right context?
Null. We can take null.
We can write this as this combination concatenation of AC epsilon followed by A epsilon epsilon null string. So right context will be null, and again the alpha value of alpha is also null. Okay. What about this? Left, right, and alpha. Left context, right context, and alpha. क्या वैल्यू होनी चाहिए?
सर सारा null moves रहेगा क्योंकि null रहेगा सारा context.
We can write this like this: null concatenated with C, then followed by null is rewritten as.
3 times
So you
null.
can see left context, right context, and value of alpha is also null. Okay. So I think,
Excuse me, sir.
huh,
Sir, please explain question number 2 again.
AC epsilon is rewritten as what? A epsilon epsilon. लिख सकते हैं कि नहीं?
Sir, A is terminal or variable?
देखिए, जो कन्वेंशन फॉलो होता है वो क्या होता है, आपको पहले भी बताया है। टर्मिनल के लिए क्या है, इस तरह के स्मॉल केस लेटर हमने यूज करते हैं, ठीक है। नॉन टर्मिनल की जब भी बात करते हैं तो क्या करते हैं, कैपिटल लेटर्स यूज करते हैं। ओके, सो ए सी इज रीरिटन एज व्हाट? ए। फाइन। तो यहाँ कॉमन दिख रहा है ना ये, तो ये क्या
Yes,
हुआ,
sir.
ये आपका लेफ्ट कंटेक्स्ट मैच कर रहे हैं। राइट कंटेक्स्ट की बात करें तो वो क्या हो गया, नल एप्सिलॉन। और अगर बीच की बात करें जो सी रिप्लेस कर रहा है, वेरिएबल इज व्हाट, सी रिप्लेस्ड बाय अल्फा, दैट इज आल्सो नल। क्लियर है
Okay. Yes, sir.
ना। अगर ये प्रोडक्शन फॉर्म क्लियर है तो हम लोग टाइप वन प्रोडक्शन को डिफाइन कर सकते हैं। ओके, phi a psi is rewritten as phi alpha psi is a production of type 1 if and only if alpha is not equal to null. Fine. ये ध्यान से समझ लीजिए, प्रोडक्शन किस फॉर्म का है, phi a psi is rewritten as phi अल्फा साई, एंड रिस्ट्रिक्शन क्या कर दिया हमने कि अल्फा इज नॉट गोइंग टू बी इक्वल टू नल। मीन्स व्हाट, इरेजिंग ऑफ ए इज नॉट परमिटेड हियर। इफ प्रोडक्शन इज ऑफ दिस फॉर्म then this type of production is called as type 1. Okay, phi is what, left context, psi is what, right context. So if you go to the first thing that we have discussed here, we have talked about what, context sensitive, ठीक है। और यहाँ अगर आप देखें प्रोडक्शन के फॉर्म को, तो लेफ्ट कंटेक्स्ट की बात हो रही है एंड राइट कंटेक्स्ट की बात हो रही है। प्रोडक्शन फॉर्म यही है। ये टाइप वन प्रोडक्शन कब होगा, जब इस फॉर्म में अल्फा जो है वो नल नहीं होगा। ओके, ये चीज क्लियर।
तो सर जो एक क्वेश्चन था जिसमें अल्फा का वैल्यू लाल जो हम लोग किए थे वो वाला फिर मतलब इससे बिलोंग नहीं ना करेगा फिर।
बिल्कुल बिल्कुल, जो हमने यहाँ पर प्रोडक्शन देखा उसमें सारे टाइप वन के प्रोडक्शंस नहीं हैं। टाइप जीरो में देखिए कोई रिस्ट्रिक्शन है, कुछ भी हो सकता है। यहाँ देखिए u इज री रिटन एज v, फाइन, वेयर u बिलोंग्स टू व्हाट, एटलीस्ट एक वेरिएबल होना चाहिए, उसके आगे पीछे कुछ भी हो सकते हैं, वेरिएबल हो सकते हैं, टर्मिनल हो सकते हैं, वेरिएबल और टर्मिनल का कॉम्बिनेशन हो सकता है। v is also going to be anything, combination of v and t, fine, but in type 1 the erasing of a is not permitted, fine. so यहाँ जो प्रोडक्शंस आपको दिख रहे हैं, फिर से एक बार देख लेते हैं इन प्रोडक्शंस को। बताइए इसमें कौन सा आपको टाइप वन दिख रहा है। तीन प्रोडक्शन है आपके पास।
सर क्वेश्चन नंबर 1।
ठीक है, ये हमने कहा फाई ए साई, फाई अल्फा साई, अल्फा इज not equal to null, that's why this is called as type 1 production. Here you are seeing that alpha is equal to null, so this is not going to be the production of type 1. Again alpha is equal to null, so this is again not the type 1 production. Okay, ये चीज क्लियर है। Yes or no?
यस सर।
Yes, sir.
So if I ask you about language generated by a grammar रहे हैं, suppose you are provided
Sir,
with a grammar G VTPS, तो क्या कंडीशन बताई थी किसी भी
It's
स्ट्रिंग
a
के
set
All
of string
string
which obey the rules of grammar.
रूल्स क्या है,
sir,
प्रोडक्शन रूल्स,
sir,
ठीक है,
set of strings
हाँ,
such that the strings belong to star closure of terminal and S is derivable from the string.
S is not derivable from the string, S is deriving in 0 or more steps W, okay, so the string is derivable from the start symbol, ठीक है, स्ट्रिंग क्या है, वो डिराइव होना चाहिए कहाँ से, स्टार्ट सिंबल से, बाय अप्लाइंग द प्रोडक्शन रूल्स ऑफ पी जो दिया गया है, तो ये चीज ध्यान में रखना है हमेशा।